Hello everybody, welcome to Marketing Analytics course. This is Dr. Shagata Chatterjee from Vijisom IIT Kharagpur who is taking this course. We are in week 7 and we are discussing recommendation engine. So, in this video and probably in the next video also, we will discuss certain examples of recommendation engine and their applications with real world data. So, in this particular data set, here we have movie ratings and where people have given ratings for movies, and I also have genre of the movies and I want to find out how I can recommend certain movies based on his genre and based on his I would say interest towards those genre, where data is being collected from, let's say, Flipkart, the IMDb, or let's say Netflix or something like that. So, here the data set, if I just read the data set, the data set looks like this. There are two data sets which we will merge. One is called movies data set, where the movie ID, the title of the movie and the genres are written here, and then the ratings data set, where basically around 1 lakh ratings are there, 1,05,000 ratings are there. User ID, movie ID, rating and timestamp, at what time point this guy has given the rating. So, I will actually find out the, so there are basically, if I am not wrong, ratings $user ID, if I am trying to find out and then find out the unique of them. So, how many unique users are there? If I am not wrong, there are 668 unique users. Yeah. So, there are 1 to 668 unique users are there, and how many movies? Basically, there are 10,329 movies. So, that is what I have. So, now based on that I have to find out, so which movie should be recommended. Now, if somebody has already rated a movie, then he will not see the movie anymore. So, then I have to find out his similar movie which he might like, and likeness data, whether he will like or not dislike a movie will come from basically the rating that this guy has provided. So, I will ask for a library called Recommender Lab and ggplot2. Recommender Lab, whatever we did before, the item based and user based collaborative filtering, this guy will do it on its own quickly. For bigger data, it helps. So, Recommender Lab and ggplot2 is two libraries that I am calling. If you have not installed it, you have to first install it, and how to install it? You can write install.packages and then the package name, or you can go here and install and write the package name here, and then that will install the package. So, I have installed the package beforehand and I am just running this thing here. So, the first thing is processing of the data. I will break the data into genres. So, for that what I am doing is I am creating a genres column. So, which is a genre column, only the genres of the of my data set, and then I am using a library called data.table, and then with this library I am breaking the genre with C. There is called string split. So, T string split will actually split the string based of the genre comma 1, that means genres first column, based on this particular sign. Whenever this sign occurs, it will just split it, and then strings as factor is equal to false and it will create a data set. So, genres 2 gets what it does. It is actually breaking, if you check genres, if it is adventure, animation, children, comedy and fantasy. So, adventure, animation, children, comedy and fantasy. So, that is how it has broken, and the rest of them are blank. So, we have created, and if I just column names of genres to, if I make it 1 to 10, now it will be clearly seen that I am actually breaking the genres of each column into separate columns. So, these are my various genres, and if I find out the unique of these genres in the whatever they are in this 10,329 observations of 10 variables, you will basically get 18 different kinds of genres. So, these are 18 different kinds of genre that is coming up. So, that is a genre list that we have, and based on this genre list I will create a matching. So, whether what is the code for this particular genre. So, if this is the first particular movies genre, so then I will create a matrix in such a way such that that matrix will have number of movies is 10,329. So 10,329 rows and 18 columns. 18 columns is each is one genre, and the value will be 0 if that particular movie falls in that genre, and that data will come from this particular matrix. And if it is not in that genre, then 0. If it is in that genre, then 1. So that is what I am going to create now. So what I am doing is that I am creating, see, there is a matrix of 0 with 10,330, that means first row will be the column name, and 18 columns. So that is what I am creating. The first row, genre matrix 1, the first row is basically the genre list, the column names, and then column names of genre matrix is basically the genre list. So that is what I am doing here. So if you check the genre matrix right now, it is basically all zeros. Okay. And then what I am doing is, for I, so I is equal to 1 to n row of genres 2, that means 10,000, 10,100, 330, and then C is equal to 1 to n call of genres 2, that means 1 to 18. What will I do? If it is matching, then 1, otherwise 0. So if I just run this thing quickly and then drop the first column, first row, see, first row I am dropping here. If I just drop the first row, then what do I get in genre matrix 2? I am getting genre matrix 2 like this. So the first movie is action, animation, children, comedy. The second movie is adventure, children, and fantasy, and so on. Now this part you can do it in different way. If you have a better algo for that, you can do it in your way. This part is similar. So I have to create this. This is something that I want to know, that which movie and which genre I am creating a mapping for that. Now next is for C in 1 to 18, n call of genre matrix 2 is 18. So C is 1 to 18. The genre matrix for each column I am changing it to their integer values. So if I just run this, it is doing nothing but changing all the values to their integer values. Now what will I do? I will create a search for a movie by genre. So this is a off topic, but this is something that helps me in developing further. So I am creating a data frame called years, which is the movie title. So years is equal to as data frame movie title strings as false. So years looks like this. So this is the movie title column basically. And then I am using library called data table to what to do? To substring. So I am saying that substring right is a function which will substring from left to right. So this is what I am doing, substring function, and using this substring function from here I will only take the years, this 1995, this 1995, this 1995 I will scrape. So you can do right how much from right side, it is like the right function. If you have used Excel, it is the right function. From the right, it is the second to 1, 2, 3, 4, 5th. So it should start from 2, end at 5. So from right side, that is what I am doing. So years is equal to, you see that 1, 4 basically is something that it is doing. It is subtracting, creating a subset, and that years is getting me all these year values of this particular thing. So again you can do it in Excel if you want, but I am doing it here. Next is I will create the same thing with a movie. So I am creating a search matrix which is binding movies data's first column, that means movie ID. Next is substring of movies 1 to, so the movie name basically only the movie name, then the years, and then the genre matrix. So when I put this and then put the whole column names, this is the search matrix that I get, the movie ID, the title, the year, and then the genre ID matrix. So this is what I have created from this. I save this so that I can use it for later purpose. So this is how it looks like basically. The search matrix will look like movie ID, title, year, and the overall genre of the movies. So you can create a pivot in this particular matrix, or you can create you can search like this: subset search matrix action is equal to 1, that means it's a movie action, and year is equal to 1995. What is the title of that? If I find out, so these are the movies which come out in 1995 and are action movies. So if you want furthermore, let's say I want action is equal to 1 and comedy is equal to 1 and 1995. So these are the movies which are action and comedy. So you can create those kind of search. Now what I will do next is I will create a binary rating. So create a user profile is what is my next objective. So I am creating binary ratings. Anything 4 and 5 is high, 3 to 1 is low. So that is what I am creating here. So binary ratings is equal to ratings, and then for if the value is greater than 3, then put it 1. If it is smaller than 3, then minus 1. So that is what I am just trying to do. Likes means 1, dislikes means minus 1. So it will run for some time, and let's see how much time it runs. So I in 1 to n row binary ratings. Binary ratings is 1 lakh. So it will take quite a bit of time to totally find out. So I will see it is now 28,000. And what I am trying to do here, basically it will go up to 1 lakh. What I am going to do is that sometimes it does not matter if there are multiple gaps, let's say 1, 2, 3, 4, 5, multiple levels of ratings, creating similarity becomes very difficult sometimes. So 1 minus 1 is basically a more or less, I would say, dichotomous. So if you like 1, if you dislike minus 1. And why did I take greater than is equal to 4 or 5? Because oftentimes we have seen that the reviews are a little bit positively skewed in nowadays. So if it is positively skewed, so 1, 2, 3 is considered to be low and 4 and 5 is considered to be high. And we are actually trying to do that. We are in 98,000, 1,05,000 will take, okay, so it is over. So I have created a binary rating. So how does the binary ratings look like? The binary ratings look like this. Basic thing, 1 or minus 1, nothing else. So you can, so this code is actually bad. You could have done a if else. Simple if else would have taken much lesser time. Anyways, so then what I do is convert this binary rating. So what I will do is I will convert binary rating matrix to a correct format. So the format is like this: binary ratings 2, which I run, and it will create a binary ratings 2, which is the movie ID. And then correspondingly there are lots of people, 669 variables means 69 observations. All these NS means nobody has given review for that, and if they have given some review, either it is positive or negative. 1 means positive, minus 1 means negative. So that is what I have got. So basically 10,325 movies and 669 users. I will got a 0, 1 matrix for that. So it's a large matrix actually. And then, so if by chance if there is nothing there, then if there is a NA, then put a 0 there basically. So I am putting 0 for all the values where it is NA, and then remove the movie ID column. So that means I am getting a 10,325 observations, which is the movies, 668 observations, which are the users, and 0, 1 and minus 1. These are the 3 values that are there. 0 means there was no rating, 1 means he liked it, minus 1 means he basically disliked it. So that is a binary rating formula that I have created. Now remove rows that are not rated from movies dataset. So there are certain movies which are absolutely not rated by anybody. So if they are not rated by anybody, why should I use them? So we are doing that. And then movies rows that are not rated for genre matrix 2 also. So any movies which has been not rated, you have to remove that from genre matrix 2 also. That is how I am creating genre matrix 3. So genre matrix 2 to 3, there are 4 movies which were not rated: 10,329, 10,225. So that means there are 4 movies which were not rated, we remove them. Similarly, movies 2 basically have 10,325, there are 4 movies which were not rated by anybody, we remove them. Fair enough. That is how we are reducing the data set. So the calculation takes less time. Then what? Calculate the dot product of the genre matrix and the ratings matrix and obtain the user profile. So understand what is the genre matrix. Genre matrix is 10,325 of 18 genres, whether this movie is belonging to this genre. And then what is my rating matrix? Rating matrix is basically 10,325 of various people giving a rating. Now, if I want to find out that whether this user is fond of comedy, then what will I do? I have seen that this user, this 668 from this binary matrix, this one, if I just click on this one, let us say user number 1, let it come and then I will say, let us say user number 1, whether he, so user number 1, if you say that 10,325 or let us say user number 2, because the data is showing here, he has seen this movie, he has not liked this movie, he has not liked this movie, and if you come down further, he has liked this movie. So, some movies user number 2 liked, some movies user number 2 didn't like. And then all these movies like movie number 14, if I go to genre matrix, I know that movie number 14 is basically a movie number 14. Movie number 14 basically is a drama movie which he liked. And then it's only a drama probably. Then let us say this one which he didn't like. Which one was that? That was movie number 3 and movie number 5 he didn't like. So, in the genre matrix I know movie number 3 is basically a comedy, movie number 5 is also a comedy, and movie number 3 is nothing else, probably romance also, movie number 5 is not romance. So, movie number 3 and 5 both are comedy which the user number 2 didn't like. So, from this information I can find out what is his net liking, the overall liking of a genre. How will I do that? Which movies he has seen, which genre it is, from there I will find out how much is rated for them, +1 or -1. So, that is what I am going to do here in the next set of calculations. So, I am creating a result which is 18,668. Why 18? That means 18 rows, 668 columns. Each column is one consumer or one user, and I am seeing that whether he has, so it is basically a sum of ones and -1s. Whether he has seen a movie in a particular genre, if he liked 1, if he disliked -1. If the net sum is positive, then overall he is liking. If the net sum is negative, then overall he is disliking that genre. So, that is what I am populating here. Quickly, so result, yeah, I got this result column. So, now if I just see this matrix carefully, what I get is user number 2 user number 1 likes the first genre most, 28, then 6th genre, the 8th genre, and probably 16th genre. These are the genres that user number 1 likes. User number 2 probably this one, second genre, 9th genre. Now, if by chance see there are two guys who are, this user number 1 is a movie buff, he watches more movie. So, the one which one he dislikes, like say 9, is still much higher than the most liked one for the second user, which is 9 here. So, he is 9 and this 9 has two different meaning. For the user 2, this 9 means that he likes the 8th genre most, but he does not watch movie much. On the other hand, this 9 means that he watches movie very much. 9 rating is actually in comparison to 28, 27, they are very small. So, it is not his favorite genre, though the overall rating is 9. So, how to check that situation? I have to normalize that. So, I am doing that. First of all, convert the, okay, so I am converting them to 0 and 1. If it is smaller than 0, 0. If it is greater than 0, 1. Now, I am creating the data set which will be used by this recommender engine, the recommender lab library, to create the recommendation engine. So, what I will do is I will create a rating mat, the library called reshape, and rating mat is getting created. Rating matrix is a large matrix which looks like this. Let me just put it up here, which is nothing but a reshaped version of the data set that we have created till now. Let it come. So, if you check it carefully, it is saying user ID to movie ID, and the value is rating. User ID, movie ID, and the value is rating. That is what is getting plotted here. And the rating matrix, all these ones are basically the user IDs in x axis, and y axis is movie IDs. Okay, so it is taking a little bit higher time. Okay, so the view is not coming properly. I will not focus on that. And then the method is UZBF. See, similarity calculation method of cosine similarity, that is what we are doing. Nearest neighbors, remember there we took 5 neighbors, here we are taking up to 30 neighbors. The library is recommender lab. The rating matrix is, we are converting it to a recommended lab sparse matrix. So, these are basically specific to this particular library. You have to use this, you have no choice. And then the similarity, basically similarity of the users is similarity rating mat 1 to 4, method is cosine, which is user. So, I am doing a user to user similarity matrix. And if I try to find out the similarity score for the first 4 guys, this is how it looks like. So, you have taken first 4, you can take the whole 1 to 668, it will give 1 to 668. I have taken the first 4 for the simplicity of calculation, and this is what I am getting the image, the similarity matrix. So, the yellowish it is, the better, that is the image that we are getting. So, this one is not coming as to be good, we have to check the red colors again once more. Then I can also find out the computer similarity between the first 4 movies. So, I can do it for the movie by movie similarity also. So, for the first 4 movie, if I try to find out the similarity, this is the similarity, see 0.9, 0.95, 0.91. So, the first 4 movies are very similar probably with each other. Now, explore the value for ratings. So, this is where I am actually trying to find out the ratings, the value of ratings. So, vector ratings is equal to as vector rating mat $data, at the rate data. So, this is a different format for sparse matrix, and unique of vector ratings. These are the various vector ratings that you got 5, 4, 3, 4.5, 1.2 and so on, and I am creating a table for that. And it will just show me what is the tabular ratings. So, vector ratings is, these are the how many vector ratings that you have got is something that has been listed here. Now, vector ratings is not equal to 0. I will only take why it is not equal to 0, because zeros are NAs if you remember. So, I am taking that and making them factored, and then if I am plotting them by chance, it is basically a histogram plot, that how many different kind of ratings that I am getting here. Then if I explore the viewing behavior with the similar way, I will not spend time on this, you will just check it. I get the viewing behavior of the top 5 movies also. So, these are the top 5 movies viewing behavior. And then if I visualize the matrix, I should visualize this one, the heat map. So, the heat map of the first rows and columns. So, this is the user rows and this is the item columns. The darker it is, the more is his preference towards that, based on the data set that we have got. Now, what I will do is, I will that rating mat, if you remember, the rating mat, this is where I am coming back once more, the rating mat data set. This is actually the one that I will use in my UCBF, the recommender lab library. So, I am normalizing it first, and after normalization, this is the values that you are getting, the item columns and the user rows, and all these ones are basically how the heat map, what is the similarity level 2 to minus 2, various items and various rows, how close it is, how is the chance of seeing this particular thing. And then I use UBCF. UBCF means user based collaborative filtering, and nearest neighbor is equal to 30, cosine is equal to, method is equal to cosine. You can change this cosine to correlation and etc. So, that is how you get the model and you find out the details of the data. So, the details of the data says that there are 668 and 10,035 rating matrix of class real rating matrix with this many ratings has been used, and these have normalized using center of rows. Now, if I want to find out the recommendation, the top 10 recommendation. So, for the first person, I am taking rating mat 1. If you change this to 2 or 1 to 10, you will get the recommendations for all the 10 guys. So, recommendations for 10, it is the top 10 list for one user is something that is been saved here in Recom. So, if you check the Recom, basically the items and the ratings and the item levels have been written here. So, the next part is basically if you want to see the Recom, this is the Recom list. So, Recom underscore list is basically the first person, the ID of the various movies, and obtain the recommendations based on this Recom list. If I just try to find out the names, then Recom result will give me the names of the movies for the first guy. So, that is how based on UBCF you can check the code properly, we are doing it. Now, if you have to evaluate, and if I am evaluate with n is equal to 1, n is equal to 3, see 1 nearest neighbor, 3 nearest neighbor, let us say 5, these are the 3 things that we are checking. Let us say 3, 5, 10 and 20, 5, 10, 20, these are the 3 guys I will check. Then how will I run it? I will just run it like this. So, good rating is equal to 5, bad rating. So, run this. The first rating is taking 5 nearest neighbor, then it will take 10 nearest neighbor and then it will take 20 nearest neighbor. And what is the evaluation score and etc. is something that we will see right now. So, okay. So, if I check the eval results, you will get it here. So, this is the eval results for 5, 10 and 20 corresponding true positive, true negative rates and etc. are giving here. So, the reference is this particular link. You can get a better discussion about this particular thing in this link. I have taken the code from that link and probably the data set was publicly available, and this is how we create the recommendation engine with rating data set with bigger data set. In the next video, I will also show you how to create a recommendation engine with a smaller data set which can still be handleable. Thank you very much. I will see you in the next video.